Okay, so now we're looking at lesson 3, operations with functions. And again, we're doing some more operations with functions. So it's basically a review, again, a little bit of grade 11. In this investigation, we'll be using the same functions f and g as in the investigations in lesson 2. So you can see this is set up the same way. What's asking for here is complete the table above for fg, f times g. We're going to multiply, in this case, the two functions. Well, that means we're multiplying f of x and g of x, and here are two values when x is 4. We're given these two values and we can multiply them together. So you can fill this table in, and I'll just quickly do that. We're going to be starting at basically, oops, a bit too thick of a pen, 49. This is going to be 30, 15, 4, this is going to be negative 3, negative 6, negative 5, 7, and 9. Now you can see this is not quite linear. It's obviously going down and then it's going back up again, so that suggests that the product of these two functions will be a parabola. They're giving you both functions right here. This is f of x and this is g of x. When we multiply them, which makes sense because one of them is x something and the other one's x something, so when we multiply we're going to get an x squared for f times g. Plot the points from the table which will fit on the grid. And so if we plot these points, at least the ones that can fit, we'll see, let's see, this one will fit, a y value of 15. These two won't fit because our scale is going from 15 down to negative 15. So this one's a little bit off scale. It's at 15, and these are going up in 1, so it's going to be way up here. Negative 2 and positive 15 is going to be about here somewhere, just off the grid on my picture. We have negative 1 and 4, so negative 1 and 4 is going to be here. 0, negative 3 will be 0. Negative 3 is going to be 1, 2, 3 down here. What else do we have? 1, negative 6. 1, negative 6. 2, negative 5. 3, 7. We're up at positive 7 now, so 3, positive 7 is actually way up here. And then 4 is going to be at a height of 9. So this is a strange looking function. It's not actually a parabola, I guess. It's coming down like this and up like this. I'm just checking if I've actually multiplied these correctly. Actually I haven't. Maybe you've picked up that mistake. 7 times 0 is actually 0. So when I was looking at my graph, it didn't look symmetrical, especially these 2 points. So this point here should be at 3, 0. Okay, so 3, 0 should actually be that point. So let's move over. 3, 0. Okay, there it is. So do not worry about that one. Cross that one off. So it does look like it's a parabola coming down and round and up. Okay, so part C here, the functions f and g above are the following, same as it was before. And it's saying here, write a simplified expression for these functions. So if we do that, we will multiply these two together. In other words, f of x times g of x can also be written as that. So we're going to multiply the following: 2x plus 1 multiplied by x minus 3. We're going to have to FOIL these out. We will get 2x squared. We're going to get plus x minus 6x minus 3, simplifying to 2x squared, and that will be plus x. Oh no, sorry, negative 5x. Change that to negative 5x. Handy dandy eraser. Negative 5x minus 3. Use a graphing calculator to graph this function. So you will see that it will turn out the way it was in the graph above if you use your graphing calculator. If you're going to graph this function here on your calculator, it should mimic what you had in the graph above. Determine the domain and range. Well, we can show that definitely domain, since it's a parabola and it opens up, it's all real numbers. Y will depend on how low it went. So I can't actually see this here, but I believe it went down as far as negative 6. So the range is greater or equal to negative 6. Compare and... Oh, by the way, on your calculator you might get a slightly different value to this. This might not be exactly negative 6, but on my sketch above, I believe it went down to that. Okay, so use your graphing calculator to determine this range, and it might not actually be negative 6. Let me think. I think your calculator will probably give you a decimal. Actually, I see it now in my answer key. It's negative 49 divided by 8, so that's a fraction. But that's pretty close to negative 6. It's a little bit lower. So use your calculator to determine the actual value to 1 or 2 decimal places. Calculate the value of f of g when x is 8. So we're going to take this equation and substitute in x is going to be 8. So let's do that. Fg when x is 8 will equal 8 squared minus 5x x is now 8, so we'll have multiplied by 8 and then minus 3. So always remember BEDMAS when you do these things. We'll have to do brackets first. 8 8 64, 2 64s, 128, minus the following 5 8s are 40, and minus 3, so we eventually get an answer that is, I think that's 85. Okay, that would be your answer. Complete the statement. In this investigation, the product of two functions whose graphs are straight lines is a quadratic. In other words, it ends up being an x squared, like this up here. Can you find two functions whose graphs are straight lines? Well, this is not the case. Don't worry about that. And we'll pause as we turn to the next page. Okay, so now class example 1, there is only one example, is saying to consider these two functions above, write an expression in simplest form for each of the following functions. Okay, a little bit of review. Here we're subtracting the functions. Here we're multiplying. Here we're replacing x by 16 in whatever we get in part 1. Here we're replacing x by 49 in whatever equation we get for part 2. So let's subtract the functions. So this is going to equal, we're going to have f first because f is first here, minus g. So 3 square root x minus 2, and from that we're going to subtract all of g, so all of the following. Put it in brackets specifically because there's a negative here, because it will have to apply to the root x and also to the negative 5, changing the signs of both. Okay, 3 root x minus 2 minus root x plus 5. Let's simplify that now. We can see we have 3 root x minus root x is going to give us 2 root x, and negative 2 and positive 5 is plus 3. So let's do part B right away here. If we use this expression here and plug in 16 for x, we can see we'll get 2 root of 16 plus 3, and that's basically 2 times 4 plus 3. 8 plus 3 is 11. So that's our answer. Up here we're multiplying, so let's use brackets. That's f. That's got to multiply g, which is root x minus 5. Now here both actually contain root x. So when we do this, we're going to have to FOIL out as per usual, but it's probably going to take a little bit longer to simplify it. So 3 root x times root x ends up as 3x. 3 root x times negative 5 is negative 15 root x. Negative 2 times root x, negative 2 root x. And then negative 2 times negative 5 is positive 10, plus 10. Okay, let's simplify this. That's going to equal 3x. And we've got basically negative 17 root x plus 10. That's basically as simple as it goes. And here this is telling us to put 49 in where we see x here and x here. So let's do that. This is going to equal 3 times 49 minus 17 square root of 49 plus 10. Simplifying that, what's 3 49s? Say 147 minus 17 times 49. Square root of 49 is 7. So 17 times 7 is 119. So it's negative 119 plus 10. And using our handy dandy calculator for all that, let's see, 147 minus 119 plus 10 is giving us an answer of 38. So please go on and do assignment questions 1 to 6 and finish off the assignment for lesson, this is lesson 3. So there is only 6 questions here. Okay, we'll see you in class.